Welcome back to another Algebra 2 video. I'm Mr. Hibble. We're still looking at operations on different polynomials, but right now we're going to start focusing on operations of complex numbers. Remember, complex numbers are this case where you have something in the general form a plus bi, where a and b are both numbers, and I had that special property. If you think back to the last unit, I was this letter that came up whenever you got an imaginary value. And remember, an imaginary value always comes up when you have the square root of a negative. Specifically, I is square root of negative 1. So what you could do with I is you can find a bunch of powers for it. We did that in class. It's not something that I'm necessarily going to go over right now. I'm just going to get to what we need to know for this topic, which is I squared. So if I have I, we know I is the square root of negative 1. And I squared then would be, well, I is the square root of negative 1, and we're squaring that, so it's square root of negative 1 squared. And if you think back to last unit as well, one thing we learned is that square roots and squares are inverses. And what inverses do is they cancel each other out. So I squared is actually just negative 1, and that's important. That is one thing that we're going to need to remember for complex numbers. Okay, let's keep that in mind as we go through this. Looking at this first problem, all we're doing is we're adding two complex numbers, 6 plus I, and then you're adding that with the complex number 4 minus 5i. Well, if we add those together, right now there is no values in front of our parentheses, so there's nothing to distribute. So remember, if there's just a plus sign in the middle of our parentheses, we can just drop the parentheses altogether and just write what was on the inside. Okay, well, from there, this is actually pretty easy considering all I have is like terms now. So 6 plus 4, those are both constants. Those combined together, they add to 10. I have 1i and negative 5i. Those are both like terms. They're both I. And if you combine those, combine the numbers in front, positive 1 minus 5 gives me negative 4. The I, the imaginary number, comes with it. That would be our answer to this first problem, just adding two complex values. Well, that process doesn't really change much when we start to subtract complex numbers. Because when we subtract, what we learned is when there's that minus in the middle, all that really happens is you change the signs. The 6 changes to negative, and the negative 2i changes to positive 2i. When you distribute a negative, the signs always change. And again, I find my like terms, I combine those. 8 minus 6 is 2. 3i plus 2i is 5i, and okay, now I have my answer. The math gets a little bit more interesting when we start to look at multiplying complex numbers. The process is still the same as multiplying any polynomial. You take one of the ways you can show that is by taking what's in the first set of parentheses and multiplying it with the second set. So 5 times 4 minus I, and the negative 2i times the second set of parentheses as well. Okay, well, when we do that then, what we have to do now is show that multiplication. We set it up, but now let's actually distribute to the inside. Well, 5 times 4 gives me 20. 5 times negative I, that would give me negative 5i. Distribute for the second set of parentheses as well, right? This is the same idea as before. And negative 2 times 4 is negative 8. Make sure the I goes with. And then you have negative 2i times negative I. Well, a negative times a negative is a positive. We would still have 2. And you have I times I. Well, remember, when you multiply something by itself, that's squared. Or another way to think about it is when you multiply letters and variables in math, you add the exponents. So I times I, they both have little ones as their exponent technically, giving us the squared now. And okay, you can kind of see what happens now is we have like terms again, so we may as well combine those. give us negative 13i in the middle, and the 2i squared and the 20 are still there. Okay, but I told you to remember something at the beginning of the video. I told you to remember something about I squared. One thing we learned about I squared at the beginning is it's the same thing as just a value of negative 1. Well, if you ever have I squared, then what you can do is you can replace it. You can get rid of I squared. You can plug in negative 1. When you plug in, be careful. Make sure you put it in parentheses to show the multiplication. 2 was multiplying with I squared originally, so the 2 should still be multiplying with negative 1 now. Okay, but all we have now is 2 times negative 1. 2 times negative 1 is negative 2 there. I didn't do anything with these other terms, so they still come down with it. And then from there, we have some like terms we can continue to combine. From here, 20 minus 2, those just combine. That gives us 18. And now we get our final answer there. One more problem to look at. Reminder here, if you have parentheses squared, what's happening is you're multiplying it by itself. And how you show that is take the 7 plus 8i, multiply it by itself. That's done by putting it next to it. Set up your multiplication. The 7 multiplies with your second set of parentheses. The 8i multiplies with your second set of parentheses. And now we just go through our distribution multiplying. 7 times 7, 7 times 8i, 8i times 7, 8i times 8i, that'd be 64. Remember, something times itself. Add your exponents there, you get I squared. Once we have that, combine our like terms. 56i's now give us 112i. The 49 is still in front. The 64i squared is still with it. But we remember something about I squared. We said I squared is negative 1. So, okay, instead of I squared, I plug in the negative 1 in parentheses. Where 64 and negative 1 now multiply to be negative 64. And we can then finish up this problem by combining our final like terms. 49 minus 64 is negative 15. The 112i is still there with it. And now you have your final answer. This is complex numbers, their operations on them, adding, subtracting, and multiplying complex numbers. Thank you for watching.